think computational neuroscience can aid experimental research?
Okay, I think this is a very good question. My short answer is yes. Computational neuroscience definitely can aid experimental research. When I was a graduate student, I was amazed by the Hodgkin-Huxley model for action potential. I think this is the best example for this question. Again, I want to use my PhD project as an example. Simply speaking, when I finished my first paper about functional characterization of voltage-gated potassium channels in fast-spiking interneurons in 2000, at that time, we almost believed that Kv3 potassium channel is required for fast-spiking action potential generation. However, we don't really understand what exactly the gating mechanisms of Kv3 under fast-spiking phenotype. To solve this question, I and my PhD supervisor tried to employ the computational approach to model Kv3 channels based on voltage clamp data acquired from my own experiments. Next, we combine the modeling with the dynamic clamp technique to inject the artificial Kv3 conductance into the fast-spiking cells, which was recorded in the presence of broad spectrum of potassium channel blockers. In this experimental condition, we can rescue the fast-spiking phenotype by artificially injecting Kv3 conductance into the recorded neurons. The computational approach is very versatile and allows us to systematically alter the channel gating, such as the activation gating alpha, deactivation gating beta, and the inactivation gating. This approach led to the conclusion that fast deactivation, lack of inactivation, and high activation ratio of Kv3 channels are essential for fast-spiking phenotype. Compared to the year 1951 or even 2000, our question today is beyond single action potential. Neuroscientists are facing more complicated questions, such as the network activities. Today, we can measure neuronal activities from hundreds of neurons in a small network. Using a computational approach, we can build up realistic network model, which is very close to the real network based on experimental data. So we can imagine if the model can simulate the neuronal activity, it may answer some key questions that experimental scientists cannot answer due to the limit of technologies. Furthermore, the model may provide some important clues or predict some important experiment for experimental scientists. So that's my answer.